Related rates, problem 1, the sliding ladder. The top of a 25-foot ladder is sliding down the side of a building at a constant rate of 3 feet per minute. When the top of the ladder is 7 feet above ground level, what is the rate of change between the bottom of the ladder and the base of the wall? This is a classic related rates problem. We immediately start organizing our information. The first thing to look at is what to find. What we are asked to find, we find that with a question mark at the end of the problem, a lot of times as a statement. We are asked to find the rate of change between the bottom of the ladder and the base of the wall, so we can visualize that bottom of the ladder moving to the right as the top of the ladder is sliding down the wall. Next comes when. In related rates, it's almost always going to be when, since it's a rate problem. And from the text, it's when the top of the ladder is 7 feet above ground level. Next, we analyze what we're given. And from the text, we're given that we have the top of a 25-foot ladder sliding down the side of a building at a constant rate of 3 feet per minute. Note that we have boxed in most of the text from the problem for these 3 pieces of information. The last thing we'll need is an equation. Before getting the equation, let's draw a picture. We have a right triangle with a hypotenuse 25 feet and the vertical leg of the triangle on the left of 7 feet. The equation that defines this triangle is perhaps the most famous equation in mathematics, the Pythagorean theorem, a squared plus b squared equals c squared. I don't know if it's apparent, but our drawing can be oriented within a coordinate plane with the x-axis along the base of the triangle and the y-axis along the left side of the triangle. It's the wall down on the left which the top of our ladder is sliding. So we can label the top of the ladder going downward as negative 3 feet per minute. So these are our givens. We have the top of the ladder sliding down at 3 feet per minute, so the change in y with respect to or over time is negative 3 feet per minute. And also we're given that the hypotenuse equals 25 feet in length. And when? When y equals 7 feet. And what are we trying to find? We're trying to find the rate of the bottom of the ladder moving away or to the right from the wall, which we call dx dt. Now we'll apply the equation. We use the Pythagorean theorem and get y squared plus x squared equals 25 squared. Next, we need to differentiate all terms of the equation with respect to time. We get 2x dx dt plus 2y dy dt equals 0. We're going to solve for dx dt, which is what we're trying to find. We can just move the 2y dy dt term to the right side of the equal sign. We get 2x dx dt equals negative 2y dy dt. So moving across the equal sign, we just change the sign of the term, and that works for us. Next, we divide both sides of the equation by 2x. We get dx dt equals negative 2y over 2x times dx dt. The 2 divided by 2 cancel to equal 1. We're left with dx dt equals negative y over x times dy dt. Now we have just about everything we need. We have dy dt, which equals negative 3 feet per minute, and y, which is 7 feet. We need to solve for x. To solve for x, we have y squared, which is 7 squared, plus x squared equals 25 squared. This is just applying the Pythagorean theorem to solve for x. We have x equals the square root of quantity 25 squared minus 7 squared, and getting out the calculator and solving, we get x equals 24 feet. So we now have everything we need to put in our equation to solve for dx dt. We have negative 7 feet over 24 feet times negative 3 feet per minute. Feet over feet cancel to equal 1, so the units cancel out. We box in our correct answer. Dx dt equals 7/8 feet per minute. It's this organization that helps to solve the problem. Find, when, given, and equation, the initials FWGE, which makes for a clumsy sort of acronym which we can pronounce as FWIGI. This has been Related Rates Problem 1, the sliding ladder. Thanks for viewing.